Good morning. Today we are going to do 4-1 right triangle trigonometry. So first we need to review how the sides of a triangle relate to an angle. So the hypotenuse is the longest side and is always across from the right angle. When we label this on the triangle, we will label it with an H or HYP, either one. So since my right angle is right here, the hypotenuse will be right here. So next we're going to talk about the legs. These are the sides that form the right angle. And we will label those sides as the adjacent side. And that is the leg that is directly next to the indicated angle. And we think of that as like our next door neighbor, the ones we share a property line with. It's touching the angle. And we will label that with an A or ADJ. So the adjacent is this one right here. It's the one that touches the angle. And the other one is the opposite side. We'll label that with an O. And this is the side directly across from the angle theta. Okay, it's the one that is not going to touch it. So if I put my finger on the theta sign, the opposite side is the only line that is not touching my finger. So let's next look at our trig ratios. So last semester, we talked about sine, cosine, and tangent. These are our main three trig ratios. These are the three trig buttons on our calculators. But there are three more that we haven't talked about, and we're going to talk about it today. All six of these only work for right triangles. If you don't have a right triangle, this will not work. None of this. Okay, and we'll find out what we need to do later in this lesson, or later in the unit. So the reciprocal of the sine is the cosecant. And this is abbreviated CS, the C of theta, and since it's reciprocal, it's simply 1 over sine, which means it's going to be my hypotenuse over my opposite. Okay, the reciprocal of the cosine is the secant, which is abbreviated SEC, which is 1 over cosine, and is therefore hypotenuse over adjacent. And finally, the tangent, the reciprocal of that is the cotangent, which is COT, which is 1 over the tangent which means it is the adjacent over the hypotenuse. So today we are going to identify all 6 ratios. But when we solve, we are only going to use the main 3 because the secant, the cosecant, the cotangent, they don't have buttons on the calculator. So if I need to solve for something, I am only going to use the main 3, which are sine, cosine, tangent. So to find the missing side of a right triangle, remember we are going to use the Pythagorean theorem. Because in order to do all of my ratios, I need to know all of the sides. So remember, this is a squared plus b squared equals c squared. You will have to rationalize the denominators today for problems that involve radicals. Remember, we can't leave a square root on bottom. So to bring it up, we need to multiply the top and bottom by that square root. So let's take a look at 2 examples of finding all 6 trig ratios. So as I look at this first one, my triangle is drawn for me, but I am still missing a side. So first of all, it says find all 6 trig ratios for angle B. So first thing I'm going to do is I'm going to put a theta in here and mark my angle so I know where I'm going from. So this is side A, and I'm missing it. So to find it, I need to do Pythagorean theorem. So it's going to be a squared plus 4 square roots of 5 squared equals 12 squared. So when I square things up, I get this. Subtract 80 from both sides. And the square root of 64 is 8. And since we're talking about the length of a line, I don't have to worry about it being -8 because the length cannot be negative. So next thing I'm going to do is with respect to that angle, I am going to put, identify my sides. So my hypotenuse is the longest side, that is 12, so I'm going to put hypotenuse there. 4 square roots of 5 is the side that doesn't touch angle B, therefore that is the opposite. And 8 is the side that does touch it, so that is the adjacent. So here we go. We're going to go ahead and do our ratios. So sine of B. Sine is opposite over hypotenuse. So my opposite is 4 square roots of 5 over 12. I need to reduce that. So that gets me the square root of 5 over 3. Next, I have cosine. That is my adjacent over hypotenuse, so that's 8 over 12, which reduces to 2/3. And the last of the main 3 is my tangent. This is opposite over adjacent. And if I reduce that, that's just square root of 5 over 2. So now I'm going to do my reciprocal identities. So what goes along with the sine is the cosecant. So what I'm going to do is I am going to take this right here and do the reciprocal of it, because that is a reciprocal identity. It's just flipping it. So I'm going to do 12 over 4 square roots of 5. So this reduces to 3 over 1. I can't leave the square root on bottom, so I need to multiply top and bottom by square root of 5. This is what we call rationalizing the denominator. On top, I have 3 square roots of 5 left. On bottom, square root of 5 times square root of 5 is just 5. Okay, next, and normally I would put these in a line, I just went up too high. So the reciprocal of the cosine is the secant. So I'm going to do the reciprocal of this right here. I'm going to flip it. So it is 12 over 8, which is 3/2. And finally, the last one, the cotangent of B. It's the reciprocal of that one. So therefore, it is 8 over 4 square roots of 5. Again, I can reduce. And I have to rationalize, so I have to multiply top and bottom by square root of 5. I get 2 square roots of 5 all over 5. So when I ask you for the 6 ratios, all I want are the fractions. And yes, you have to tell me which one it is, so what you see here is exactly what I expect. But we are not going any further. We're not figuring out what B is because all of these would give me the exact same answer for B. So on 2, how is it different? Well, it doesn't give me the triangle. So first thing I need to do is I need to draw out a right triangle. I'm going to mark my angle theta and know that this tangent is opposite over adjacent. So when I mark my triangle, I know this is my hypotenuse, this over here is my opposite, and this is my adjacent. So my opposite side is equal to the square root of 3. My adjacent side is 3. And now I need to do Pythagorean theorem to find what's missing. So it'll be square root of 3 squared plus 3 squared equals c squared. So that's 3 plus 9. I get 12. And to undo a square, I take the square root of both sides. I need to go ahead and write what this multiplies by. So it's 4 times 3. So the square root of 4 is 2. I don't know the square root of 3. It stays inside. So this is 2 square roots of 3. So from here, we're going to do our ratios. So I have sine of theta. So that is square root of 3 over 2 square roots of 3. My square root of 3's cancel out. Leaves me with 1/2. Cosine of theta is 3 over 2 square roots of 3. Again, I have to rationalize the denominator. So I get 3 square roots of 3 all over 2 times 3. In this case, my 3's will cancel out. So I'm left with the square root of 3 over 2. And next is tangent. So that is just square root of 3 over 3. That's as far as that can go. So next I have the cosecant of theta. So that is 2 square roots of 3 over square root of 3, which is just 2. Secant of theta, that is 2 square roots of 3 over 3. That's as simple as it can go, so I'm just going to leave it. And finally, my cotangent is 3 over the square root of 3, which means I need to rationalize. So I end up with 3 square roots of 3 over 3. Those cancel out. I just get square root of 3. So there are my 6 ratios. Now let's talk about solving. So to solve a triangle, we are going to find all the sides and angles of the triangle. So if you're asked to solve a triangle, you need to find everything that is missing. We are going to use trig ratios, and the Pythagorean theorem, to find missing lengths of sides of a triangle. So if I need to find a side, I can use a trig ratio or Pythagorean theorem. If I want to find a missing angle, I am going to use inverse trig ratios. Which means I need to hit second and whatever the key is, whether it's sine, cosine, or tangent. So if I wanted to find, if my equation had a sine, to find the angle, I would hit second sine, or sine to the -1 of opposite over hypotenuse. Okay, so in my calculator, I'd hit second sine. If you're using Desmos, find the one that says sine to the -1. Same with cosine. So it would be cosine to the -1. And tangent would be tan to the -1. You are not, these aren't reciprocals, these are inverses. Okay, so please don't get these confused with your reciprocal identities. And sometimes these will be called arc sine, arc cosine, and arctan. So if you see arc and then a trig function, it's telling you to take the inverse of it. Okay, so a couple things we need to talk about before we get into these examples. But again, remember, hit the second button on your calculator before the trig function. So the things we need to know when solving triangles: capital letters, or theta, will always represent angles. Lowercase letters will always represent sides, and the interior angles of a triangle equals 180 degrees, or the two remaining sides, angles, let's try that again. Add up to 90. We are going to round all of our angles and sides to the nearest tenth, unless I tell you otherwise. And your mode in your calculator or in Desmos must be in degrees. Make sure it is before you do any of these calculations. So let's take a look at some examples. So for these first three, we are going to simply solve for the variable. When I do that, first thing I'm going to do is I'm going to mark my angle. Next thing I'm going to do is I'm going to put the sides that matter. So the sides that have something, I'm going to label them. So 15 is my hypotenuse. X is my opposite. I am not going to label the blank side because if I do, then I have to figure out what I need to use. But if I only label what I need, my answer should jump out at me. So what trig function only involves hypotenuse and opposite? It is sine. So we're going to go ahead and write that out. So sine of theta equals opposite over hypotenuse. Now I'm going to plug in. So I get sine of 32 equals x over 15. To get the 15 out of the bottom, I multiply by it. Please put the 15 in your calculator in front of sine of 32. And when you do, you should get 7.9. Again, going on to B, same process. I'm going to mark my angle. I'm going to put what I know. So I know adjacent and opposite is the tangent. So I'm going to plug in tan of 27 equals 21 over x. I can't solve for x in the bottom, so I got to bring it up. So I get x tan of 27 equals 21. Divide both sides by tan of 27. And for this one, again, I'm going to mark my angle. I'm going to label. So this is my adjacent. This is my hypotenuse. I know that has to be cosine. So first thing I do is I write the formula. And now I plug in what I know. So notice here, I don't know the angle. So this is the one where I have to write theta equals cosine to the -1. That's how I bring it over. Of 4/7. So in my calculator, I hit second cosine, 4 divided by 7. When I do, I will get 55.2 degrees. Okay, let's look at the last two, which is solve the triangle. So on this last section, it says solve the triangle. So we need to find everything that we are missing. So in the first one, I first look at my angles. I have angle A. I have angle C. So angle A is 33 degrees. C is a right angle. B is what I'm missing, so I need to find angle B. And then I label my sides. Sides are labeled across from the capital letters, so this is side A, this is side B, side C. And I know side B is 5.8. So the two sides I am missing are A and C. You will always be asked when solving a triangle to find 3 missing parts. So first, let's start with angle B. It's the easiest one to do. I know the non-right angle of a triangle, I have to add up to 90. So the measure of angle B will be 90 minus 33, which is 57. So now, if I label everything with respect to 33, B is my adjacent. That is my one, the one I know, the one I will always use. Now, if I want to find A, I'm going to label that is my opposite. So what trig function uses opposite and adjacent? That is your tangent. So I'm going to say the tangent of 33 equals my opposite over my adjacent. So I will multiply both sides by 5.8. And I will get A is 3.8. So now for C, I'm going to go back again to my adjacent, but now I'm going to label C. C is my hypotenuse. So what trig function uses adjacent and hypotenuse? That is my cosine. So it's going to be cosine of 33 equals 5.8 over C. So I'll multiply both sides by C. And then divide by cosine of 33. And I get C is 6.9. Okay, last one, A, or 7. Again, in this case, I don't have any of the angles, so I'm going to have to find angle A. I'm going to have to find angle B. And now I'm going to go ahead and put on there what I know. So this is side A, B, and C. Side A is 23. Side C is 45, so the side I'm missing is B. So first thing I'm going to do is I am going to use Pythagorean theorem because I have two sides of a right triangle. I can use Pythagorean theorem to find side B. So it's 23 squared plus B squared equals 45 squared. So I'll subtract 23 squared. So I do 45 squared, enter, minus 23 squared, enter. You should get 1496. Then I'm going to take the square root of both sides. So this reduces to, if I factor it, it goes into 4 and 374. So this ends up being 2 square roots of 374. Okay, or at this point, since I said you could find everything to the nearest tenth, just plug in square root of 1496, and I will get 38.7. Next, again, I am going to use what I know. So I am going to first find angle B. So with respect to B, this is my adjacent, and this is my hypotenuse. That means I need to use cosine. So it's cosine of B equals 23 over 45. So to find B, I do second cosine of 23 over 45. I will get 59.3 degrees. So next, I'm going to look at everything with respect to A. So with respect to A, this is still my hypotenuse, but now this is my opposite. So this is a sine function. So sine of A equals 23 over 45. So A equals sine to the negative 1 of 23 over 45, which is 30.7. And if I did it right, these two should add up to 90 degrees, which they do. Now, I know some of you are going to say, well, once I found B, couldn't I just subtract from 90 to find A? You can, but if I made a mistake with angle B and used angle B to find angle A would automatically be wrong. So that is why I always use what the problem gave me as long as I can to find an answer. And then I can use the check method to see if they add up to 90 to make sure I got them both right. As always, if you have any questions, let me know.